So today we're going to be talking about the differences between rocks, crystals, and minerals. So first, why should I care? Why should I bother studying rocks and minerals? And there are three main reasons we study rocks and minerals. The first is to know how we find and utilize natural resources. Coal, gravel, things that are used in construction, uranium, the precious metals that make up your phone, all of those things, we gotta know how to find them and how to use them. So it they come from rocks and minerals. Second is to prepare for and try to prevent natural disasters. If we understand how the rocks within the earth work and interact with each other, then we can understand earthquakes, volcanoes, sinkholes, landslides, and be better prepared for them in the future. And third is to learn about the natural history of Earth, like we've been learning about rock layers and fossils and relative and absolute dating. Rocks tell a story, and all rocks have a story of their past within them, so we can tell what has happened over time. So the difference between rocks and minerals. All minerals are rocks, but not all rocks are minerals. Rocks are a solid chunk of something that is composed of many minerals. A mineral is a solid substance that has a crystal structure, and it's got to be four things. It has to be naturally occurring. You could go outside and pick up a mineral, not grown in a lab. Two, inorganic. It can't be alive. Three, it has to be solid. And four, it has to have a definite chemical structure. Elements and chemicals are the building blocks of minerals, and there are over 4,000 known minerals from different combinations of elements and chemicals. Crystals, on the other hand, are a different thing. They are solids with a defined, very specific structure. All of the atoms in a crystal line up in a very specific location, in a very specific distance from each other, and it is the structure that matters, that makes it a crystal. Not all crystals are naturally occurring. You can grow crystals at home using hot water, a stick, and sugar or salt. So it is not all crystals are naturally occurring, so they are not all minerals. Minerals do have a crystalline structure. So typically, minerals will form crystals or have a crystal-like shape, but it does not necessarily make it a crystal. Especially important to note that two or more minerals can have the same chemical composition, but the different crystalline structures. So graphite and diamond are made of the same stuff, but they are arranged in very different ways, which make them two different minerals. Next, how do minerals form? There are four main ways a mineral can form. First, it can crystallize from magma. When magma or lava cools down and hardens, elements combine. So the first way you can form a mineral is from this magma or lava cooling down. And usually these are minerals that are made up of iron, calcium, and magnesium. The second way is precipitation. When water evaporates or when there is temperature change, what might have been dissolved in the water before gets left behind when the water evaporates. That is a kind of crystal that is really easy for you to make at home if you wanted to try making your own crystals. Third is changes in pressure and temperature. Existing minerals, like existing rocks, can go through changes with heat and pressure. So the atoms will rearrange themselves, maybe take on a different crystalline structure, and you will get a different mineral. And the fourth way you can form a mineral is through a hydrothermal solution. When you've got a hot mixture that's got chemical reactions happening with existing minerals, it can form new minerals. And also, as they cool down, it can form new minerals. So really what we're going to be working on today is how can I identify minerals? And there are lots of different properties that we can use to determine what mineral you're working with. So the first property to know is the crystal form, is the structure. Does it look kind of like a cube? Does it look kind of like an octagon? Is it a flat mineral? Just what shape is it? Second is the luster, the ability to reflect light. Is it shiny? Is it glassy? Is it dull? Third is color, just as it naturally appears. Looking at a crystal, that looks orange to me. Or looking at a mineral, that is a green mineral. That isn't always super reliable though, because if it's dirty, or sometimes minerals can just naturally occur in multiple different colors. So what is more reliable is what's called the streak. This is the color of the mineral when it's powdered. So if you grind the mineral down, it will form a powdery dust, and the color of that is constant, no matter what color the actual outside of the mineral is. Third is the hardness of the mineral, which is how resistant it is to scratching. This is the most reliable way to tell what the mineral is. Next is the cleavage or fracture of the mineral, which is how it breaks. Does it break along smooth planes, or is it very jagged and rough? Third is the specific gravity. How much does it weigh compared to water? And there are a bunch of other ones you can use. Density, flexibility, how does it feel? Does it glow under black light? Does it react with acid? Sometimes you can taste minerals to try to tell the difference. So those are the kinds of things you can use. So in a bit more detail, here are some examples of different lusters. We typically think about metallic versus non-metallic. Does it look like a metal? Does it look glassy or vitreous? Is it dull? Is it pearly? It can be both dull and metallic. Or this submetallic is like, it looks like maybe I just need to wipe it off and it would then shine like metal. The cleavage and fracture, a mineral has cleavage if it breaks along smooth lines. So in this picture here, I can tell it's cracked. This mineral has cracks in it, but all of them are along these smooth, straight lines. It has fracture if the mineral breaks on jagged surfaces, if it looks more all over the place. Hardness, we use what's called Mohs hardness scale. It's a scale from 1 to 10 about how resistant is this object to being scratched. So you might have heard people say like diamonds are the toughest stones, or you can only cut diamond with diamond. Diamond is the hardest thing on the Mohs hardness scale. And so a diamond with a hardness of 10 can scratch anything under it, but cannot be scratched by anything else. Let's look at a different example. Quartz has a hardness of 7. That means if I rub quartz against fluorite, the quartz will scratch the fluorite. If I rub the quartz against the topaz, nothing will happen to the topaz. But I could use the topaz, which is harder than the quartz, to scratch the quartz. So you can be scratched by things higher than you, and you can scratch things lower than you. Lastly, it is important to know about what different elements that build minerals are. The most abundant minerals that we see on the surface of the earth are known as silicates. They are made up mostly of silicon and oxygen, and that is like 3/4 of the land on earth is made up of minerals that are silicates. Next most common is the carbonates, which are made of carbon, oxygen, and whatever other things you need. And the next most abundant in the crust are made of things like aluminum, iron, calcium, sodium, potassium, and magnesium. So those are just common elements that are going to come up. Next, we're going to be looking at a mineral identification lab where you will be using those different properties and a mineral ID chart to see if you can identify some mystery minerals. Bye-bye.